The broadcast is now starting. All attendees are in listen-only mode.
Hello, and thank you for joining us here at Automotive Logistics as we present our latest webinar from... My name is Louis Yakumi, and I'm the publisher of the Automotive Logistics Group. As you know, this webinar will focus on how the next generation of yard management systems are driving higher efficiencies for OEMs and LSPs. Over the next half hour or so, we'll be hearing from Matthias Berlit, the VP of Inform's Manufacturing Logistics Division. A physics graduate, Matthias joined Inform in 2001 and has built up a wealth of project management experience across a variety of supply chain management projects within different industries. He's now responsible for supply chain planning and execution solutions for their manufacturing customers. Matthias will talk us through how these customers, including Volkswagen, Indonesia Port Corporation, and ICO NYK Line, achieve the next level of efficiency by using the yard management system SyncroTESS. As you listen to him explaining the success factors needed to deliver on time and under budget, I'd like to invite all of you attending this webinar to draw up some questions. After all, this is an interactive event. Matthias will then be pleased to answer these in the questions and answer session that will follow immediately after their presentation. You can ask these questions by typing them into the box at the bottom right-hand side of your screen. Also, if you experience any technical issues during the session, please type a message detailing the problem into the same box at the bottom of the screen, and our team will do their very best to resolve them. We hope that you'll find this webinar stimulating and informative, and it's now time to hand over to Matthias so that he can begin his presentation. So over to you, Matthias.
Yeah, thanks, Louis. Hello and welcome to everybody to this first Inform Automotive Logistics webinar. It's great to have so many people online with us. And what we are going to cover today in this webinar are different ideas, concepts, and technologies which bring more efficiency to the operation of, in general, auto yards, or more specifically, they can be plant compounds or distribution centers, large maritime, ro-ro terminals, etc. All these ideas and concepts are available in the SyncroTESS compound management system, and they have been implemented at various customer installations, as Louis mentioned already, and are, if you want, proven solutions. What we are not going to cover are basic features of such a yard management system, such as handheld applications to record some input from the floor, basic screens for dispatchers, etc. For the time being, we take all these basic components as granted and focus on, let's say, these new and more advanced concepts and solutions. As there are quite a number of areas we would like to present in this webinar, everything in this webinar is rather high level, and each single concept is not going to be presented in too much detail level. Of course, at any time later we can go into more detail if hopefully lots of you people like to do. So let's take a look at the next generation of yard management system. But before I start doing that, I would like to kick off with a rather short introduction of Inform. And well, actually, I'm presenting here right out of our head office in Aachen, Germany, right from the heart of Europe, very close to Belgium and the Netherlands. And here at Inform, and Professor Zimmermann founded Inform in 1969, a professor from the Technical University of Aachen, responsible for operations research. And his main focus and purpose to found the company was to prove that operations research with mathematical optimization, heuristics, fuzzy logics, and other technologies can actually help companies to work more efficiently and thus provide larger benefits to these companies. And well, today, more than 450 people are working in 6 different business divisions, and besides others, we are active in areas such as large distribution centers and hubs, just as here in the picture from the Swiss Post, or in container terminals, some of them highly automated, as for example, right here in this example at the container terminal in Hamburg, where all these vehicles here shunting containers from the yard to the cranes are automated guided vehicles controlled by SyncroTESS. And also here the cranes are semi-automatic, where only the last step, when the container is dropped on a truck, for example, a user somewhere here in the control room is using a joystick to do that last step of the maneuver. We are active also at airports, actually at more than 150 airports worldwide, where we plan and execute all ground activities, from check-in personnel to passenger buses, fueling the airplanes, bringing catering to the airplanes, and assuring a de-icing, for example, in these supposed to come fierce weather conditions. So we coordinate basically all activities needed to make the plane leave again as fast as possible. And of course, we are active in finished vehicle logistics, where we provide tools for network planning up to smartphone apps used by individual truck drivers for an electronic proof of delivery. But this webinar covers, as said before, only the compound management part of the whole solution. So what you see in this picture, basically all aspects to manage such an operation here. From time to time, we make surveys in the different business areas we work in, asking our customers and also the general public of these business areas for current topics and trends in these markets. Just very recently, we conducted a study for finished vehicle logistics, and it was quite remarkable that a large majority of the people asked ranked IT as a decisive factor for competitive advantage. But at the same time, they mentioned that there are quite some hurdles to overcome in order to invest into new IT. And there were basically two reasons. One was high costs for the IT and associated low IT budgets. And secondly, no awareness of a possible business case in order to have a return on investment. And well, then these last two topics is exactly what we are going to take a look in our webinar here. We will start off with these ideas and concepts in order to make the planning and operation of an auto yard more efficiently. And then in the second step, take a look at the technology and what we can do as an IT and software provider in order to make it more easy and with less effort to implement our software. So after this quick introduction, let's dive into the yard operation. And you see here an abstracted view of the yard with down here the general truck gate, having trucks entering and leaving the compound, having a railhead over here with an associated yard, having a vessel operation for unloading and loading, having maybe a production for a plant compound, having maybe in the middle a workshop or a PDI center, a VPC, a vehicle processing center, or whatever name there is for such an operation for technical services. And then, of course, here the large yard used to store all the cars. And you can see here we have numbered 5 different areas which we are going to take a closer look at, and how to implement new ideas and concepts in order to make it in a more efficient, in order to run the operation in a more efficient way. So advanced yard planning, what do we mean with yard planning? Yard planning is to have a plan for the next couple of days. So it's not about the operation today, but it's about how the operation should look like tomorrow and the days after that. And the motivation in order to do that is most obviously, well, first of all, to use the yard most efficiently, and then secondly, to answer questions such as where to berth a vessel which is supposed to arrive tomorrow, how to accelerate loading operation, maybe by having an intelligent yard plan where to unload the vehicles to, and well, to assure that all cars are actually ready for the next vessel or train because there are high numbers of winds to be made available, and it's important to have really the right cars available to or ready to leave maybe tomorrow or later. And so this is just a small set of all the questions you can possibly ask at that point. In order to have an advanced planning at that point, we have various inputs. One of the inputs is, of course, most obviously the current status of the system itself. So the current occupation of the yard, which vehicles have which position and which financial status, which logistical status, etc. Then the system receives advanced shipment notifications, usually by EDI from customers and OEMs, and we offer web portals in order to have an input, for example, by dealers to call off vehicles or by carriers to report which cars they will bring tomorrow. All this leads then, or is the input for the yard berth and resource demand planning solver. As the number of vehicles we are talking about for such a planning can be quite high, can easily go into the tens of thousands of vehicles. The first step the solver is doing is to group the vehicles into logical batches. As you can see here, we have indicated different batches in different colors, and each batch represents such a logical group of vehicles. For example, these green cars could be cars with the same brand, with the same model, and with the same kind of destination. For example, they all need to go to local dealers, and therefore they all need to go close to the truck load lanes. And other batches can have other characteristics. For example, the violet ones could all go to the rail yard and therefore need to be stored close to the rail head. So we are not speaking about tens of thousands of vehicles in that moment, but we are speaking about a couple of hundreds of such batches maybe. And the result then of the optimizer is displayed to the planning people in such a graphical view, where you see here on the right side the different transport means, like the trains, the trucks, and vessels. And here we have opened the individual details of one particular train with different inbound batches. As you can see here, inbound, there are Citroëns with a certain model, and then headed or planned to be stored in a particular yard. For example, here BB1, where BB1 is the yard over here. So in this map view, you see indicated in the color red the yards or sub-yards where the cars are supposed to be stored in. The planner can at all time make changes to the plan, create new batches, for example, when we didn't receive the batches via the EDI, for example, and re-optimize the yard until he's satisfied with the result, and then finally apply the changes, and then the actual operation is running to this plan. He can also extend the view a little bit. For example, here we have included now the outgoing batches, in this case indicated by the color green. So indicated here is the 20th of November, for example, the screenshot, and you can now drag and drop the slider to the 21st, the 22nd, and then see which vehicles or which areas in the yard are supposed to become available again and which are going to be occupied again. Here in this Bordeaux color, you see that here the planning optimizer considers these yards as simultaneously cars getting stored in there and cars getting removed from it. So with this, of course, you can also get a higher utilization of the yard, as we are not waiting maybe until the next day until you can store cars in a yard which is being emptied. Well, another view of the same data is given here, where for each yard or sub-yard, it's a hierarchy in a tree view here, you can have the capacity, the occupation of that yard, how many spaces, maybe in meters, are available, the utilization, and then also the defragmentation index over there. Yeah, defragmentation meaning when I have a scattered distribution of cars in a yard, then it can mean that a single car can block a whole lane, and therefore I don't have the whole utilization, the whole storage capacity of the yard actually available. And then I could automatically create move orders in order to have these yards being sorted out again. And this is done then automatically, and if the planner wishes to do so, he can initiate this defragmentation. The results of this advanced planning is you can minimize the distances, for example, for unloading a vessel, and thus have an accelerated loading operation. If you imagine you have 1,000 cars being unloaded from a vessel, and you have an optimum position of the vessel at the berth and an optimized and very close by yard for these cars, and you save something like 50 meters or 100 meters easily per car, you can imagine how many kilometers you can easily reduce your distances. While the yard utilization is maximized, as mentioned before, you can have an early identification of shortages, for example, of people not being there or of cars not available for a vessel. And you can have an advanced resource planning to fit the actual demand. So to identify the number of people I need in a gang for unloading, the number of people for an inspection, and later we will see also the number of people necessary in the technical center. All right, this was the first item here, advanced yard planning. The second item is located here at the truck gate. And well, a typical situation there at the truck gate is that you have typical peaks at the gate, usually early in the morning at 5 o'clock, at 6 o'clock. Lots of trucks are piling up. You have a high manual effort for registration. You have sometimes long waiting times, especially for the truck drivers, poor planning possibilities as the yard operators don't know when which truck is supposed to arrive, but also the carriers cannot rely on a certain throughput time or lead time of their trucks in the yard, so it's difficult for them to dispatch them for a next transport order. And sometimes you have necessary overtimes because of delay at the gate. Well, the solution to that is basically in two steps. One is a truck appointment system, which is pretty easy, that the yard defines the capacity. For example, the capacity of the number of trucks it can handle per hour, and offers then the time slots in an internet portal. The carrier announce their trucks in the web portal and book a time slot. And each truck receives then a unique transport ID, which can be used for the registration process, then again at the gate. And maybe they can print out some loading documents already then, and the yard itself can prepare for the arrival of the truck. And secondly, then at the arrival of the truck at the gate, you can implement a self-check-in process. So use the existing information which was previously inputted into the web portal, and then having such a self-check-in terminal. You can see here, this is actually a photo from ICO in Antwerp, I think this is, and where the truck drivers can report themselves. Of course, such a terminal needs to be as easy as possible and available in multiple languages. Well, and secondly, you could also combine it with a smartphone app for regular truck drivers. So then there's a 2D barcode on the smartphone, and similar to this check-in process at an airport, where you take your smartphone, have your email from your airline, and then go until the plane only with this smartphone. You don't need a boarding pass. Exactly the same can be implemented also here. Actually, this last step with scanners at the gate for these 2D barcodes, we haven't implemented yet. All right, possible results. Well, you don't have a language barrier at the gate anymore because it's automatic and it's with these screens. Then you can save time for basically everybody involved there, for the carriers, for the drivers, for the yard people. it allows a preparation in the yard. For example, you can organize and take out the right cars for the truck just before the truck is supposed to arrive. So if for the truck is you have a time window at 1 p.m., the operational optimizer would make sure that at 12:30, for example, all cars would be available at the load lanes. But you wouldn't need to make that at maybe in the night before, because you don't know when during the day the truck actually arrives. Well, you have reduced traffic jams, at least at the gate. If all people show up at 5 o'clock in the morning, you still have the physical trucks there, but you have time windows. So only the trucks which have a time window are going to receive the access to the yard. And you have more reliable throughput times, because once the carrier has booked a time slot, it can really rely, because you have a higher discipline to the whole process. The dispatcher of the carrier can really rely on a throughput time of maybe an hour and dispatch the truck again. On average, you could say every truck, every driver who is following this process can at least save 20 minutes per truck arrival. And you can imagine, if you have tens or hundreds of trucks arriving per day, you can imagine how many time you can save per month. All right, optimized yard operation. Now we are speaking really about these individual people moving cars from yard to yard, or doing inspections, or doing maintenance jobs, or whatsoever. And well, the motivation here is well, to get rid of a paper dispatch, maybe. I know a lot of yards where job cards are printed and then handed over to a supervisor or bus driver, and then people are working on these job cards. Then, of course, you don't have the possibility to decide in real time where to park which car, and how to minimize distances and reduce the number of movements and so on. So basically, the question is, who is moving which car first? And again, here, also, the solution is done in 2 steps. First, you need an intelligent parking solver. So when you take a look at this situation up here, this car needs to be stored in this yard. And of course, it makes a difference if you park the car up here, first in line, or at the last spot over here. Now, for example, it could make sense that a fast mover is stored right at the first position in that lane, or a slow mover could be put into that lane. On the other side, it's actually a little bit more complicated. If these cars are all fast movers and you put a slow mover here, well, then it's not so good, because you lose capacity in this yard. So these are all aspects the intelligent parking solver needs to consider. And we can make the whole situation a little bit more complicated also if we simultaneously consider also cars which need to be removed from the yard. So let's assume that these 2 cars need to be removed and maybe put to the load lanes. It, of course, makes a difference, or can make a difference, where to store this car. Because let's assume that this car has a certain urgency and priority to it. So it would actually make sense to store it as close as possible to this car, in order to have a best follow-up order for that driver. And this leads over to the second part of the solution, the intelligent assignments. Here we see the actual worker who is driving the car. He maybe has a handheld in order to communicate directly with him. And the question is now again, or the question where to park the car is answered by the parking optimizer. And now the assignment optimizer is assigning this move order to this driver over here. So he gets into the car, reports to the system back that he's moving this car, reporting he has stored it here or parked it there. And the optimizer in the background, while moving the car, is already looking for the best follow-up order, and has identified, because of the intelligent parking optimizer, that this car needs to be moved out of the yard again. So of course, this is a best follow-up order. And the driver sits into this car, again communicates via the handheld, and again the assignment optimizer is looking for the best follow-up order. And here are other vehicles which need to be removed from the load lanes, for example, or from the storage area in front of the VPC. So it's you can build circles, as you can see here, for the drivers in order to have a much higher utilization of each driver. Of course, this cannot be applied everywhere. If you have a unidirectional flow, for example, from the production into the yard, then you don't have orders to move cars back into the production. And there you still need buses, and you cannot do so much. But everywhere where you have, let's say, more or less the same number of cars need to be put into the yard and needed to be put out of the yard, there you can work in such an operation. You can also reduce the number of movements. Let's assume that right before we assigned this order to move the car here, a dealer called off this car. So we already have a dealer allocation, and now actually the car can be stored immediately in the associated load lane. So the optimizer then would assign or would do a recalculation and assign the driver with a new destination, and you would actually get from 2 steps to a 1-step operation, reducing also, for example, the probability for damages. And again here, also there, these circles can be built. Results, of course, well, you have a reduction of buses where possible. You have a reduction of the number of movements. You can have an optimized and real-time dispatch of your drivers. And besides the movements of the cars, also inspections, maintenance orders, repairs, etc. can be optimized in that way. So you can consider priorities and also changing priorities all the time. The experience shows that about 10 to 30% these people working in such an environment can be more productive. All right, so in the workshop, there you have the task that you have cars you need to process in this workshop, in this vehicle process center. And the question is, are all my parts available in order to fulfill my tasks? How much labor do I need for it, for all the cars I want to process tomorrow? How long does which job take? Yeah, and where do I lose money maybe because I'm taking more than I calculated for? And questions like which cars have priority? And of course, there's a whole set of other questions which can be answered. Therefore, the optimized planning, located here in the middle, is considering, of course, basic information from the VINs, all characteristics to it, especially important the target date, when does the vehicle need to, is scheduled to leave the yard again, about the resources, the qualification of people you have in the technical center, and then the second item here is the order input, which can be received automatically via interfaces from the customers, entered manually, or a damage can lead to a repair order. All this is recognized and considered by the optimizer together with the actual stock of all parts involved. So here all relevant stock you can actually track. I would not recommend to track each screw, of course, but each major item you want to track can be considered here, and also a replenishment order can be automatically triggered. The optimized planning results are then optimized move orders to bring the right cars at the right time to the vehicle processing center, and also internally the execution of each job can be monitored and tracked. And this, of course, has in return an effect on the stock level. Over the time horizon of a couple of days, this looks that you usually would do the planning on the day before, move the cars either on the evening or night before, or maybe even during the day, have the execution in the VPC, move the cars from the VPC back to the yard or directly to load lanes, and have from the planning also a next day planning and a forecast for the next couple of days. Now, always taking into account the damage and order input and updating the stock level. As the result, Well, you process the right cars where all parts are available and with the right number of people. And secondly, and very interesting of course, is that you have the chance to actually analyze the profit and losses you do with particular jobs because you record all the necessary information. Well, last but not least, optimized load building. The motivation here is to actually optimize this. Yeah, a truck with several different types of cars on the back, different sizes, and on that total pictures. So you can have a whole country with hundreds of dealers with a complex traffic network underneath. And in the last couple of years, we have implemented and are still refining this optimizer, this load building optimizer, which works basically with a traffic and dealer network, can consider different vehicle sizes, which are then grouped in different vehicle sizing groups, and with different truck types. The result of the optimizer is then presented. Usually, if you have a situation like this one here with maybe 500 or 600 cars for a day, the optimizer comes back with the result after 10 or 20 minutes. And then you see here in this pictures all trips are made active, so it's very complicated to see that. But you can see here easily that this is, for example, a route which services 4 different dealers on this route. And well, as a result, most obviously, you have less total distance because this optimizer is just able to take a look at the whole complex situation at one time. So you can also assure a higher load factor. And we could show that you have a reduced transport budget by 5 to 12% for this, in particular for this last mile delivery to the dealer. You have, of course, also a reduced manual planning for this transportation, and therefore also the chance to have a dynamic re-optimization because it takes only 10 or 20 minutes. So if the situation changes, you can make a re-optimization. Well, this was the first part and the larger, by far larger part regarding possible business cases and assuring a return on investment of IT costs. And secondly, we would like to show very shortly what we did also on the technology side. So how to make it as easy as possible and as fast as possible to implement such a system. Well, first of all, it's quite obvious that it's very important to set up the yard correctly with all singular details, then have also different ways of analyzing this yard and, for example, having an indication here of the utilization of the yard, having different zooming factors. For example, here I see the whole utilization of the yard, and I can zoom into this in order to take a look at how many actual cars do I have in the yard. Well, then all base data of the system are all absolutely VIN specific or finished vehicle logistics specific. So we are speaking about a make, a model, about hold types, about damages, etc., etc. And very important for this, let's say, ever-changing environment. You get new customers to your yard, you get new requirements from production, and well, there we offer a tool to actually model the business case, the business processes. As you can see here, this is a receive VIN. We call it work scheme, which starts off here each time a VIN is received, for example, unloaded from a truck. We start with setting some starting values, and then there's a question, are all VIN information available or complete? Yeah? Did I receive an announcement for this VIN? If true, I can immediately start with the next process. If false, I create a missing information hold for that car. If true, I go into this create hold section, and again, this whole tag here stands for a new business process, where again, I start with starting values, and then I have decision tags. For example, is this VIN for export? If yes, I ask again for which customer, and then I can apply letter of credit holds based on, well, for this VIN and based on the customer. Yeah? And this is not just a graphical representation for the visualization of the process, but this is actually how the system is working after that. So when you have a change, or when you set up the complete system anew, then you can use this tool which we created in order to draw the business processes. As you can see here, this is a colleague of mine who made now a change to this create hold work scheme. And let's assume that we received a new customer, and the customer has the requirement that also for import cars they want to create a certain hold. So of course, most obviously, the VIN is not for export because it is for import. So we say if the VIN is for import, we go here, we ask again for the customer, and now we execute some commands. And you can see now on the lower side, well, down here, you can not read it so good, create hold is the associated command to it. Yeah, and with this command, SyncroTESS actually is performing or putting a hold on this car if all these characteristics are fulfilled. And with this, most obviously, you can adapt to new requirements, to new customers very easily. And it's only a matter of maybe a couple of hours to set up a new process, and not a matter of a couple of days. Right. So actually, the result is a much faster time to market and a lowered cost for changes, and thus also for IT. Also, for the integration part, we have implemented some interesting features. Integration is highly important for such auto yards, and you need to connect to all these different parties. What we have on the one side is a standard SyncroTESS API, so standard messages, a standard language to communicate with SyncroTESS. So if you have an information broker or another system, then they can adapt to SyncroTESS. On the other side, we have a special agreement with ICO and can use their complete interface setup. So ICO in Antwerp and Zeebrugge are working with maybe 20, 25 different brands together and have implemented hundreds of messages. And we can use this actually iWay message setup and apply it also to other customers in this cooperation with ICO. And then we offer standard web portals for carriers, customs, dealers, and so on, so they can enter information if needed. And all that leads to a much faster system implementation and thus also reduced cost. Well, secondly, I wanted to show you here some new module for business intelligence. And here, this is actually a third-party product. We have set up here a demo system for the compound management system. And this third-party product is using in-memory technology. So all necessary historical information are in the actual memory. And it is very fast in order to acquire information. On the left side, you see here various filter possibilities. For example, on the month, on the year, on certain dates, on models, makes, down here on customers and carriers. And, well, you can very easily press on such a filter, as you will see just in a minute, and then immediately here the graphical representation which we set up will change. You have, for example, now filtering for November, now filtering for a couple of days in November. Yeah. And you see the speed this tool assures. And this is really a lot of fun to work with and to really do a deep dive into the figures. Well, as a conclusion, I think we could show that with these new solutions, we provide interesting ideas in order to actually receive a business case. And with these new technologies, we can assure a lower total cost of ownership of the whole IT solution. And this is what we call the next generation of yard management system, which allows a next level of efficiency. All right. Thanks a lot. And Louis, well, took me a couple of minutes longer now. I hand over to you again.
Thank you very much, Matthias. A very interesting presentation on the next generation of yard management systems. I'd like to open it up for questions from the participants. So if you have any questions, please input by writing in your question at the bottom of the screen. We've got a couple of questions already, but we've got a few minutes for the questions. So if you've got anything that you want to ask Matthias, please type your question in the box, and we'll try and get to it. A couple of questions that we've already got, Matthias, so far is one of the questions which comes from a shipping line. Which areas or processes in an average yard form the bottlenecks and or prevent the yard from operating as efficiently as possible?
Well, especially in maritime terminals, I think that the sheer number of cars which are supposed to be loaded and unloaded on vessels really make a challenge, in order to provide the right number of cars in the right status at the load lanes. And so the bottleneck is actually the sheer numbers there at that point. Bottlenecks, what you can observe every day at the terminals, is the gate, as mentioned before, these peaks early in the morning. If you show up there at 6 o'clock in the morning, and sometimes you see a long queue of trucks waiting there. I was one time at a plant in Mexico. I saw a line of more than a kilometer of trucks waiting there. It depends a little bit on the operation and if it's a plant compound or if it's a maritime terminal. But I think these two areas are most of the time the most challenging ones.
Okay, thank you, Matthias.
Because also the other areas you can easily work with more people. Yeah, and therefore you can, for example, to organize the yard and do the operation inside the yard, it's easy. If you just simply, let's say, put more people in there, you will get to manage that. But with these number of vehicles for a vessel or a train, it's always challenging, and also at the gate it needs more technology in order to do so.
Okay, thank you, Matthias. The next question from a vehicle maker in Europe is the input from host systems in a specific format, and is the system online?
Yeah, the system is working online. It can be hosted if it's hosted at Inform or at the customer. This is a question to be discussed, but both is possible. Online, meaning in real time, yes, of course, the system is real time, and also doing the integration in real time. So there's not a batch processing. Of course, some legacy systems require a batch process for exchanging data, and then we can also do that. Regarding the format, we have different possibilities. So most of the time, if we are speaking with an interface to an OEM, we adapt on our side our system to the OEM system. At other points, it is possible that the third party is using our API, our standard interfaces, and is programming against that. Yeah, but again, there we need a discussion and what is the best way for which purpose.
Okay, thank you. Another question from a vehicle maker. Why is it called next generation? Isn't it available, and who are the actual users and where?
Yes, it is available. We internally have the latest version 10, and well, because of these aspects from business process modeling, for example, and all the optimizers implemented here, especially for finished vehicle logistics, we think it is a next generation of auto yard management systems. We have used a lot of concepts from other industries, for example, from container terminals. You remember this intelligent planning optimizer. And with container terminals, you have the same topic. Yeah? You need to decide where to store the container and not block other containers, etc. So we took the idea and also part of the optimizer from that area. We think it's true to have, let's say, the next generation of yard management systems. Where is it in place? We have almost on every continent. Yes, I think on every continent we have implementations. Just recently implemented the system in India, for example, in Thailand, in Indonesia, in Europe in a couple of countries, in Mexico also. So it's running at a lot of operations.
Okay, thank you. And on that kind of global note, just to let you know that amongst the people listening in come from Mexico, Japan, North America, India, Western Europe, Russia, China, Brazil, Africa. So, you know, it's obviously interest globally for what you're doing.
Yeah, cool.
So also you sponsor our conferences globally as well, so thank you for that. But the next question, again from a car maker, is can the unit transit the compound several times?
Yes, of course. Yeah. Examples for this is a dealer return. Let's say a dealer doesn't accept the car, other reasons, and then actually when receiving this win, maybe we don't have an announcement, but we take a look at our database and would in that instance get the information back out of the database. Yeah, so because we have a difference between a historical database and the operational database, but this wouldn't be a problem there, but we would actually get all information which were recorded previously for that car back into the productive system.
Thank you. Next question is, which VIN characteristics can be used to optimize loading a rail car? For example, wheelbase, model, age, etc.
Well, right now we have this load building optimizer specifically for trucks, but this can also be used for rail cars, and actually we have done that also at one particular customer. And what we did is that we have implemented, or let's say configured, the different configurations which are possible. So, well, depending on where you store which car, it makes a difference if you can put, in this case it was 15, 16 or 17 vehicles in that wagon. And so to answer the questions, yes, of course, the model and maybe the model sizes can be considered, the age in order to decide which vehicle to transport first, and well, basically everything what would be necessary in this particular case. Yeah,
Okay,
I think at that point we would need a further discussion with that party.
Another question, is GPS accuracy enough for your system?
Well, you can work with GPS for plausibility checks, but normally, well, either you can have connection to an RFID system, or we simply use handhelds or maybe smartphones where the drivers can confirm that they have parked the car in the location which we assigned the car to, and then have a plausibility check with the GPS. We have also in interesting situations, like in launch situation in plants when they launch a new model, the situation that the cars are parked basically everywhere because they are not allowed to leave the plant because the vehicle is not on the market yet. So they have the problem that they don't have enough space in that moment, and they park the car on every field and on every green parking island they can find. And in that moment, we can also save the GPS coordinates, and later, because it is not a particular parking space where we can say it's in yard A and block 1 and lane 5, but in that case we can give on the handheld the information where the car is on a map, and then the driver or the people can follow this ping on the map and go and take a look at the car. But we don't, let's say, we don't rely on the GPS information to decide in which lane, for example, and in which space the car is stored. You would need a differential GPS in order to make it as accurate as necessary, or work with RFID. And then again, there's a question regarding passive or active RFID, etc. But this is another topic, I would say.
Okay, thank you very much. That question was actually from Japan, so thank you very much for that viewer for staying up to listen to the presentation. One more question. As we focus very much on the outbound side, on the finished vehicle logistics side, but do you do something similar, or if you can briefly explain your offerings to the inbound side as well?
Yeah, actually we started something like 25 years ago delivering solutions for the inbound logistics, also in automotive, and also for the finished vehicle, for the outbound side. If we take a look at the, let me quickly show here. If you take a look here at the yard optimizer, these are again aspects which we used previously in the plant where we dispatch forklifts to bring material to the assembly line, or this truck appointment and self-check-in. This is actually used in more than 50 automotive plants worldwide in order to optimize the supply chain. And so yes, we can deliver similar tools also for the inbound side.
Okay, another question from a car maker. Does it provide specific functions for ports, for the shipping of vessels, etc.?
Yes, there is, well, first of all, this berth planning, where you decide on is it better to berth the vessel over here or a little bit further here, in order to minimize the distance between the vessel and the yard. For example, here it's quite optimal. And also there's, I would rather call it a simple way for planning also the vessel loading. So what we do quite, let's say, sophisticatedly for the truck and load building for trucks, we have a first version also available for vessels in order to implement or consider the different decks and fill the decks with the right cars. But this is still in the beginning.
Okay, thank you very much. I think that brings us pretty well up to the hour. We've had some very interesting questions from different sectors of the automotive industry, from car makers and LSPs and IT companies, from all around the world, as we said. So thank you very much, Matthias, for your very interesting presentation. Thank you to Inform. I'd like to thank you all.
Thank you.
I'd like to thank you all very much for joining us. Please remember that this webinar will be uploaded onto our archives and made available to anyone who wishes to view it. You can access this and all of our previous webinars under the Events tab on the Automotive Logistics homepage, which is automotivelogisticsmagazine.com. Thank you again, everybody, for joining us today. Thank you.
Thank you, Louis. Thanks, everyone. Goodbye.